Well, welcome everybody to today's hybrid event featuring a discussion with Paul Triolo about his paper titled South Korea Caught in the Crosshairs of U.S. China Competition Over Semiconductors. Paul's paper will later be published in KEI's flagship journal, Korea Policy, Volume 1, Issue 3, which we hope to have published before the end of the calendar year. And I just will say more broadly, Issue 3 examines the concept of economic security from different countries' perspectives, and also includes various articles more specific to the Korea's particular issue areas, from energy security, critical minerals, and as is the case with Paul's paper, on semiconductors and U.S. tech competition. I do also want to highlight Volume 1, Issue 2 of Korea Policy was recently published. You can get a hard copy in our foyer, or we will drop a link as I speak to the digital version online. And if you go to that link, you can also see, for most of the papers in Issue 2, the events that we ran alongside the papers, much like today's event. So turning to today, we're very pleased to have Paul Triolo join us to speak about his paper and share his considerable insight into South Korea's complex and challenging position amidst broader U.S. China tech competition, particularly over semiconductors. And we've put his longer bio on our website, so I don't want to read the whole thing, but just a few highlights for those who are unfamiliar with Paul and his work. He is a Senior Vice President for China and Technology Policy Lead at the Albright Stonebridge Group, or ASG, where he's also an associate partner. He advises clients in technology, financial services, and other sectors as they navigate complex political and regulatory matters in the U.S., China, the EU, India, and really around the world. And among a range of other experiences and qualifications, he spent more than 25 years in senior positions in the U.S. government, analyzing China's rise as a technology power and advising senior policymakers on a broad set of technology-related issues. So to put it simply, you really can't read about the issues we're going to discuss today without, you read a handful of articles and you're going to come across Paul being quoted and sharing his insight on the issues. So his paper, as he will soon discuss, examines how South Korea finds itself in one of the more complex positions among countries with advanced semiconductor industries, as the broader global industry really faces restructuring, as it's buffeted by U.S. export controls and industrial policies on one hand, and China's reaction to some of these policies and some of China's own policies on the other, and how the South Korean government and some of its lead firms, particularly Samsung and SK Hynix, are navigating these challenges. So just briefly, in terms of run of show, Paul will present his paper for 20 or so minutes, after which we'll turn to some questions that I've prepared ahead of time, and then we'll turn to you, both in-person audience and virtually as well, for audience Q&A. And if you do have questions online, feel free, as Paul presents and as we discuss afterwards, to enter those, and we will turn to them during the Q&A. So without further ado, Paul, thank you for joining us.
Thanks for that introduction. So I was very honored to be asked to write this paper. I think it's one of those issues that hasn't been a lot of in-depth, sort of analysis of this problem. It's a complicated problem to come at. There was a good paper written last summer by a good friend of mine, Mark Terzempa at PIEE, which tackled some of these things, and I referenced that in the paper. But I think it's a tricky issue because it really requires getting a little under the hood of where the industry is on some of these issues, because the controls and the industrial policy that Clint mentioned, it's buffeting the entire industry, but certain parts of the industry, in more fundamental ways. I think and it's important, I think, to understand where some of these pressures are coming from. So in the paper, I tried to lay out sort of how did we get here, because as we arrived at October 17th, for example, this year, there was a lot of stuff that led up to the outcomes of that, and then some of the other associated decisions that have impacted both the industry more broadly, but very specifically memory and South Korean companies that are such key players in that industry. So I'm coming at this from very much an industry point of view. We have clients all over the semiconductor supply chain, if you will, or supply chains. I think there isn't just one supply chain. And so I'm sort of on a daily basis steeped in the the issues that the industry is grappling with as they respond to these twin things, which are, it's easy to say, like, export controls and restrictions and industrial policy, but actually the detail of how those play out on a day-to-day basis is pretty complicated, particularly for companies and countries outside of the U.S. China competition or outside of the U.S. So just to, in the paper, I try to step back a little bit and say, how do we get to the point where U.S. export controls are, for example, being enforced extraterritorially? And so, this is a process that came out really of the Trump administration, with initial efforts to put restrictions on Huawei, on U.S. suppliers of Huawei. If you remember, I can still remember where I was in May of 2019 when Huawei was put on the entity list. It's like when JFK was assassinated or something. And because that was a bit of a surprise. It happened just after the U.S. trade dialogue sort of fell apart. The initial agreement fell apart, and within about a week, Huawei was on the entity list. Now, and that was a really big deal. It started a chain of events which have led up to some of the things we can talk about later. But I think then the big deal was the biggest sort of takeaway from that was that pretty quickly it became apparent that that the impact of that was not what some in Washington had hoped for, in part because the export control system wasn't really designed or had been designed in an era when when there were small companies with simple supply chains that maybe manufactured one component of a weapons of mass destruction related system, and it wasn't really designed to target and to impact a company like Huawei or ZTE, which had been also part of the debate on the entity list, which had these very complicated global supply chains. That originated in many countries and jurisdictions. So the next year was spent internally to the U.S. government trying to figure out a way to use so-called choke points, or areas where the U.S. companies controlled critical technology, to figure out how to make that export control more effective. And that resulted in the 2020 invention, if you will, of the thing called the Foreign Direct Product Rule, and its application to Huawei. And that immediately took what had been sort of a bilateral thing, right? I mean, the controls on Huawei originally came out of the Iran sanctions, a violation of Iran sanctions, right, which was very much a U.S.-centric thing. But with the Foreign Direct Product Rule, this meant that U.S. export controls now extended globally to any company using U.S. technology to produce semiconductors on behalf of Huawei. And so that's a big deal, because right away that involved Taiwan, TSMC, Samsung, Korea, maybe to a lesser degree SK Hynix, but it involved any foundry or any company that was manufacturing semiconductors. So that was a big sort of watershed moment. My friend Kevin Wolf talks about that as being sort of an unprecedented thing. But then that also, I think, has kicked off a longer term debate about the sort of multilateral export control system, which includes the Wassenaar Agreement, which has also been used to extend certain parts of the U.S. export control system to other countries in a sort of multilateral format, and that's important too for our story here. So I think that sort of, it's important to note that was a really critical date and a critical policy, which we're still seeing the ramifications of. Now, the other thing that is important to note here as we sort of work our way towards where we are now is that for the first time in the Biden era, and actually for the first time in any kind of formal setting, we had last October the articulation of what the U.S. was trying to do with technology controls in general. So last year we had First Secretary Blinken in May put technology competition at the center of U.S. China relations. And then in September, October, we had National Security Advisor Sullivan articulate what I call the Sullivan Doctrine, which was importantly three parts. The first part was the U.S. wanted to maintain an absolute lead over China in technology. The second one was he characterized as a small yard, high fence. This was an idea that had been kicking around within academia for a while. You want to control small numbers of technologies and put high barriers around them. And then third, the National Security Advisor Sullivan stressed that Advanced compute, biotech, and green tech were strategic pillars of key importance to U.S. national security. Now, advanced compute includes semiconductors, semiconductor manufacturing equipment, AI, and quantum computing. And that's an important subset of technologies. And of course, that sort of sounds a little bit like a bigger yard than the small yard high fence concept. And that's important to note. And then pretty quickly, within that context, we got the October 7th control package last year, which was also another watershed, because again, that was a massive expansion of controls over specifically advanced compute and high performance computing related technologies. And importantly, I think probably even more important were controls over semiconductor manufacturing equipment. And in addition to that, the October 7th package included so-called end-use controls and controls on U.S. persons. And so this was a very comprehensive package designed to blunt China's ability to manufacture advanced semiconductors. And it cut across a whole range of technologies. So I think that that's sort of the backdrop then, because I think even up to that point, probably South Korea and South Korean companies hadn't been impacted, to a significant degree by the sort of controls up until that point. But after that point, we have there's definitely a sort of sea change in how this impacts South Korean companies. And of course, the other thing happening at the same time last year was the U.S. CHIPS Act coming out in August. And then, that's been a process we're actually probably going to have the first grants coming out in December, but that's the industrial policy piece. And so for the last year, that's been churning forward. And again, South Korean companies are involved in that. Samsung has already committed to, for example, to a big upgrade of its facilities in Texas. SK has committed to a packaging and R&D facility. So that's another important backdrop, because now the important thing that I try to bring out in the paper is these two things are linked together, right? So one, actions in the export control arena can impact the calculus of companies in the sort of industrial policy and friendshoring, onshoring, whatever you want to call it, that arena, which really has heated up over the last year. So those two sort of poles, I think, are important to note. So as we looked at October 7th, there were three really big pieces of the puzzle here that on the sort of control side that have ended up having a big impact on South Korean companies. So the first was was a previous set of controls around advanced lithography equipment, which was already in place, of course, as of October 2022. And that was around specifically extreme ultraviolet lithography gear. The U.S. had gone to Wassenaar in 2019 timeframe with controls on EUV, and that meant that companies in China were likely to have a license denied if they tried to purchase EUV equipment from ASML in the Netherlands. And we saw this with leading Chinese domestic foundry SMIC, may have already had a contract that was actually then the license was not approved by the Dutch government in that timeframe, 2019 timeframe. And then as we'll see, other companies need, and particularly in logic, would like to use, of course, EUV equipment. And memory is a little bit more complicated because the timetable, the roadmap for memory is different. But suffice to say that companies in any part of the semiconductor manufacturing business need to keep moving up the value chain using the most advanced technology and have access to the latest and greatest tools. And so if you can't plan on that, then that's a big issue for companies who have typically 3 to 5 to 10-year timeframes with their CapEx expenditures, for example, and the tooling, which is a very important part of any business model for manufacturing semiconductors. So the multilateral controls were in place. Then we have, of course, the October 7th package. And I think, again, the most important parts of that were the end-use controls, which set as nodes requiring a license for selling tools at 18 nanometers for DRAM and 128 layers for NAND Flash. And of course, both of those technologies were being and are being manufactured in China by South Korean companies. And then the other thing, the final thing was the guardrails around the CHIPS Act. And so those just actually came out recently, but it's been known that they were in the works for a long time. And those were guardrails on investment in front-end manufacturing facilities in China for recipients of CHIPS Act funding. And the exact details of that have been complicated and been negotiated over the last year. Originally, they were intended to be negotiated on a company-by-company basis. And then they ended up being put out as sort of broad guardrails provisions. And that's affected companies in China like TSMC and like, of course, SK Hynix and Samsung that have front-end manufacturing facilities. It's really directed at front-end manufacturing. So if we look at each of these, in the paper I try to lay out a little more detail, each of those those restrictions and how to think about them when it comes to South Korean companies. Just a couple of really quick highlights for each of those. I think for EUV, again, if you look at the roadmaps for that technology, it's really several years out for the use of EUV, for example, in DRAM and NAND flash. And for both of those, probably more important ultimately for DRAM than for flash. Flash memory, as you probably have noticed, a lot of the advances are in layering. So 128 layers was the restriction, for example, that was put in the October 7th package. But already companies in China were beyond 128 layers. That wasn't really even the cutting edge. You're getting 256, and well beyond in terms of layering. So that's been the trend in that industry. Although there's lots of complications about different types of layering and different types of technology used there. But probably, if you look at the roadmaps, and I try to lay this out in the paper a little bit, we're not talking about sort of a high demand for EUV for memory until the 2025, 2026, 2027 timeframe. But all the major companies are looking at EUV, right? This is different than for logic, which is already, the cutting edge has already been using EUV now, probably since the 2018, 2019 timeframe. TSMC, but only right now, TSMC, Samsung, and Intel are using EUV because of the expense. These systems cost $250 million. And you have to have a really big customer base over which to amortize the cost of that. So EUV is a really tricky technology to deploy, and then the economics, of course, have to be there. But for memory, again, the thing to remember about memory is it's a commodity. There isn't much really legacy. For example, nodes or mature nodes in memory. It tends to be very cutting edge, and it's a very, very different market from logic. And I think that's an important point to make as we talk about the October 7th package. So EUV is one thing, and again, I think as of now, if a South Korean company in China tried to apply for a license to get it, or tried to buy a system from ASML, the license would be rejected. That's the Wassenaar control is a country control, but it does give the Dutch government a lot of leeway to determine the licensing. But what has happened is when, for example, in the case of SMIC, none of this is really public, but there's been a number of media stories written about this. It's likely that the U.S. government went to the Dutch government and laid out its case to deny the license to SMIC in that case. And so it would be a little bit different calculus in the case of a South Korean company because those companies, for example, would argue they have in place very tight controls over the technology. So it wouldn't really be possible to divert that technology to another Chinese facility. We're talking about systems that take 3 Boeing 747s to deliver, and it takes months. It takes 8 months to set up those ASML systems, 8 to 9 months. And so there's really little chance that those systems could be diverted. And companies like SK, of course, and Samsung have very tight controls over the technology in their facilities in China. So it's a very different animal, in other words, than denying a license, for example, for a Chinese fab that's operating in China. And so I think that's an important thing to know. And that when you talk to people in this industry about this, of course, those companies like SK and Samsung, which have huge sunk CapEx in China in those facilities, of course, they would like to be able to move up a normal sort of the value chain in terms of technology and pursue a roadmap which all companies have in place to determine where they're going next. So that's one sort of big factor that's there that hasn't really been solved. So coming out of the October 7th package, just quickly, we had those end-use controls, but what happened was there was some confusion on October 9th or October 7th. That was a Friday. I think October 9th was a Sunday, because those controls, those end-use controls, forced all U.S. toolmakers to pull their people out of those facilities in China. And it turned out that those facilities included facilities owned and operated by South Korean companies, including Xi'an and Wuxi with Samsung and SK Hynix respectively, and in Dalian, which is a complicated facility that is owned by SK, but it's operated by Intel until 2025 under the terms of the sale of that facility. So Intel has responsibility for the tooling there. And so there was a sort of a scramble over that weekend to put in place an exemption letter that exempted those companies, those multinational companies in China from the controls for a year. And you know, what was surprising to many in the industry was that that hadn't been considered previously, because those facilities, for example, in South Korea or in China, operated by South Korean companies, produce 40% roughly of their global output of those semiconductor memory modules. So if those facilities had to shut down, that would have had a huge impact on the market right away, right? Because this is a very market-driven and dynamic market where supply and demand matter, you know, on a sort of day-to-day basis. And so apparently we were within hours, actually maybe the minutes, of those facilities having people having to be pulled out of those facilities before this letter was issued. So at a minimum, it sounds as though somebody didn't realize that was going to be a problem, and so it's interesting that this happened. It's a little surprising that more attention wasn't given to this. And then, of course, the last year has been spent in trying to figure out what to do about that extension, whether to extend it for another year, whether to figure out another solution. So in mid-October, we did have the release finally. And this has been a big issue going back and forth. I won't go into the details. A lot of debate about what to do about this. But eventually the solution that has been landed upon, and this involved, of course, a lot of back and forth between the South Korean government and the U.S. government on the conditions for this. Those companies, Samsung, SK, were put on the so-called verified end user list, which essentially allows the tool makers, for example, to ship tools to those companies without a license. And again, the controls in October 7th were very sweeping in a number of areas, and were very specific in terms of end use. So this exempted those companies, the tool makers, from this licensing requirement. And for them, it's a big deal because, for example, with the uncertainty about what was going to happen next, the tool makers weren't able to, and the companies were not clear what to do about shipments of new tools. It takes about 8 months to design a tool and then ship it to the factory. These aren't things you pull off the shelf and buy. And so with the uncertainty about whether this 1-year extension would be granted, for example, for another year or 2 years, it was difficult for those companies to continue, for example, upgrading those facilities, which is happening all the time. The tooling is being changed all the time. So this caused a lot of heartburn, shall we say, in the industry about that issue. So that. If I had talked to you about 2 months ago, that would have been a big issue between the South Korean government and the U.S. government, because the companies in China and the tool makers were very concerned about how that was going to be resolved, because these are big facilities. They require a lot of tooling and maintenance, and we're talking big money here. So then the third one, the CHIPS guardrails, I think I won't spend too much time on that, but that's another big issue because of the requirements about levels of investment in existing front-end manufacturing facilities in China. And basically, that's been another subject of a big set of negotiations between the U.S. government and the Korean government over the last year in terms of what that was going to amount to. because this covered both advanced and legacy facilities in, quote, foreign countries of concern, meaning really meaning China. I think that there's still some confusion ultimately about how this is going to be implemented. The numbers that are being bandied about in terms of levels of investment allowed, 5% or 10% of existing sort of levels of investment, I think it's still unclear to me how that's all going to be actually implemented and how it's calculated. But again, both SK and Samsung are participants in the CHIPS Act, and so that will likely be is being negotiated even as we speak as part of an agreement for the grants and incentives that are going to be granted under the CHIPS Act. And again, it was originally designed to be something that the companies negotiated directly with the Commerce Department and worked out on a sort of company by company basis. I think that's an important part of the equation going forward to see how that actually happens, because again, even though those companies operating in China cannot, as of now, upgrade their facilities to EUV, there's still a major technology roadmap to upgrade those facilities and amortize the costs over the next 5 to 7 years, and then there's an ongoing question of sort of investment to expand those facilities, and then there's a question of investment to keep those facilities going, and how that's all going to be calculated. Because in talking to a lot of U.S. government officials, for example, over the last year, one sort of message that seemed to come through was, well, the U.S. government would prefer that those facilities eventually shut down in China, right? Or that those eventually are phased out. That was sort of, at one point, the message that seemed to be coming out of this issue. Now, to sort of just, and I noted in the paper this, I think it's important to say that from the industry point of view, there was quite a bit of surprise and consternation that memory was even included in those end-use controls, right? Because originally, it did not appear that memory was going to be part of this. But for whatever reason, memory was included. And the argument from the industry is this is a commodity. It's very different than logic. And so the sort of national security argument around memory is, should be different. That's at least what the point of view of the industry. And I think that's very much the point of view of the South Korean government and the companies. Because again, remember, these are facilities in China that are generating revenue, for example, for Samsung and SK, and one of their arguments is, and they have a lot of arguments for why it's not a good idea to control, memory in general and control the tooling to those facilities in general, is that those facilities are generating revenue that SK and Samsung can use in part to also invest in facilities in the U.S. under the CHIPS Act. This is the same argument that Intel is making, for example, about export controls that result in the cutting off of its markets in China, some of its big customers, because they're on the entity list, because they're being asked to build facilities in the U.S. And so Pat Gelsinger says things like, well, if you cut off 35% of my revenue from China, then I don't need to build more fabs because who are my customers? So the way to look, I think, at the memory issue is similar, which is that those facilities in China, where I think Samsung, I was looking at the capex numbers, is something like 25 billion in capex in those facilities, and that may not represent the whole way to look at it. But I think again, those are big numbers, and so if you're asking these companies to build new facilities in the U.S. or in Korea, and they're counting on sort of that sustained revenue over a decade or whatever from China, that's a big deal, because the numbers in the commercial part of this, there's sort of a technology roadmap and there's a commercial roadmap, and those both have to make sense for companies to be making these big investments, right? And I think so that this is sort of where the industrial policy piece comes together with the export control piece, which is, and why companies like SK and Samsung are really caught in the middle of this, and why they needed to have some further certainty about both the end-use controls and the sort of October 7th package and how that would be extended, and then trying to get to some level of certainty around the guardrails, because otherwise, if their accountants are running the numbers, for the next decade and trying to understand how they invest incrementally, for example, in the U.S., it becomes very complicated if you don't know if you can't count on certain kinds of revenue streams. So that's a big deal. And then finally, let me just, and I mentioned in the paper, there's other sort of interesting pieces of this as we go forward. There's just three quick things. One is, I think, at some point this is going to generate, and already has, calls for some sort of different export control regime outside of Wassenaar, that because Wassenaar is dysfunctional now because Russia, of course, is a member. And so if you're going to argue that export controls are a good tool to control technology and China's access to technology, then arguably you need a different type of system, because even the existing export control system in Wassenaar were not designed for the purposes that it's being used for now, right? So again, those were designed for weapons of mass destruction. They weren't designed to maintain U.S. technology leadership or to punish companies for human rights violations, right? There's been a lot of churn about this. Emily Benson at CSIS just came out with a paper arguing for some scenarios about how you get to a post-Wassenaar world. So that's one thing. And I think South Korea is going to be a key part of all these discussions, because when it comes down to it, Wassenaar includes a lot of countries, but for semiconductors, there's only a few countries that matter, right? Taiwan, Japan, South Korea, U.S., and EU, and certain countries in the EU. So you could see a smaller group of like-minded countries come together around some sort of new export control regime. We've already seen this a little bit with the Japan and Netherlands participating and sort of aligning to some degree with the October 7th controls. And so that's something to definitely watch, how South Korea plays in that. You've seen, I didn't mention the CHIPS 4 alliance, which I probably should mention in the paper, but that's something that came out of the State Department, a State Department initiative to sort of coordinate around industrial policies. At one point they said they wouldn't deal with export controls because that's sort of a different issue. That really has gone nowhere as far as I can tell, the CHIPS 4 Alliance, in part because a lot of the stuff, the CHIPS Act is really performing that function, because the CHIPS Act and the CHIPS Program Office, for example, are coordinating with Japan and South Korea and Taiwan in terms of their companies' investment in the U.S. And so there's already some effort there. So that's one thing to watch going forward, is does the industrial policy side of this involve more coordination between the key players here, including the EU. And then finally, on the export control side, interestingly, you have another situation in China where the U.S. controls led eventually to the and the inclusion of YMTC, which is the big competitor to South Korean companies, and CXMT, both in NAND and DRAM, to be put on the NA list. And so this resulted in Micron, the leading U.S. DRAM maker, they also do some NAND, being targeted by the Chinese for a cybersecurity review and an apparent ban on some of the sales, some of their products to Chinese critical information infrastructure operators. And so that is important because in the context of that, Korean companies were asked not to backfill for Micron. And that's a very complicated issue because, these are commodity products too. Companies may not know what channels their products are being sold and who they're going to. And so that was, when I talked to South Korean players in this, there was a lot of confusion around that, because this is a market, it's a market-driven sector. So to ask a company not to exercise its market prerogatives, even in a case like this, was what many felt was sort of a bridge too far. So that's yet to be seen, how much impact the Chinese ban or restrictions on Micron will affect that market. Many people in the industry think that it will have a big impact on Micron. And then the question of what companies sort of end up benefiting from that is still to be seen. But I think probably South Korean companies will have to step in and supply some of these end users in China. And then finally, the Huawei Mut 60, which came out in September, is another interesting angle to this, because in that phone, which was produced by leading Chinese foundry SMIC, but also includes memory from SK Hynix, and so that was as a result of a teardown. DRAM and NAND was found in the phone. SK is doing an investigation of how that got there. But again, this is memory that could have been, it's a commodity, could have been stockpiled It's older DRAM that they found in their DDR RAM. And so that's another example of how the Korean companies, and particularly memory, is a big issue, because in China, the end-use controls coming from October 7th have really put a big question mark over the future of China's domestic semiconductor industry. And so it makes the role of non-Chinese companies in the memory sector even more important, because it's an area where probably Chinese companies can't replace Western companies, for example, to be providing that really critical component for things like smartphones. So in that case, I try to cover all those issues in the paper, and I've already thought of other things that probably should be added in there as I've been talking to Clinton and others. So, but really honored to have a chance to try to lay out some of this stuff. And then I think the really key is sort of where we go from here on all this, because I think for those companies, while some of these issues have been resolved, at least temporarily, the extensions, through the verified end user listing, and the guardrails is probably something they can work out. There's still the bigger issue of that longer sunk capital investment in China, and how that works out in the context of those companies also participating in things like the CHIPS Act. And in general, the industry is under a lot of stress from those two big issues of export controls and industrial policy. So let me stop there.
All right.
Sorry, I went a little bit over.
No, that's okay. Thank you very much, Paul. One of the things we strive, and we ask our authors to strive to do with Korea policy papers, is to thread the needle between, and this is not easy, between making it compelling to an already expert audience, but also being informative to people, sort of neophytes to it, right?
This is not a topic for. I've had that issue before, where like if you dumb it down too much, then it's
sure.
It gets. But I appreciate that. You need to sort of strike that balance,
right? And I think your paper does a good job of that. And I know there were some folks online who were asking, where is the paper? So the paper, just to clarify, I think I said this at the start, but to reiterate, will come out in volume 1, issue 3 of Korea Policy before the end of the calendar year. So after some updates and whatnot, it will be available. So I had a few questions. Actually, listening to you, I've thought up some more questions, but I'm going to stick to the ones that I previewed to you ahead of time. And just start with the one that I cited, TSMC's founder, Morris Chang's. He called the U.S. effort to reshore semiconductor production a, quote, very expensive exercise in futility, end quote. And so I asked you sort of a two-part follow-up to that. What do you think of this critique of his? And relatedly, what challenges do South Korean and, of course, other foreign firms face in moving forward with their already considerable investments in semiconductor fabs here in the U.S. Under the CHIPS Act?
No, it's a great question. And we've been working with companies that are applying for CHIPS Act funding. One of the things, of course, that Secretary Raimondo has stressed is workforce development, and I think that's probably the biggest challenge here, right? I mean, because you have these places like Taiwan and South Korea and to some extent Japan, where there is a long history of advanced manufacturing, for example, in not just semiconductors, but arguably, of course, most importantly in semiconductors. And so that means the education system is sort of tuned to the needs of advanced manufacturing. The economics are sort of there, right, in terms of the workforce and how much you're paying them and how you're compensating them and how they're being trained going forward. So in trying to sort of reverse the trends in the industry, which, we're 30 years or 40 years in the making, right? Sort of optimizing essentially around, say, memory around Seoul and logic and foundry capacity around Hsinchu and Tainan and Taichung, right? The forces that led to that were market-driven, largely, some government intervention, but largely, I think, driven by innovation and smart engineers and good business models. So now governments are trying to sort of reverse that, and so they're doing it at a time when, of course, building a cutting-edge fab costs $40 billion, at a minimum. And so the economics are tricky right off the bat, right? Because you're reversing the economics have led to this sort of division of labor, and now you're saying, well, we don't like that because of other complicated national security reasons or and concentration in Asia, for example. But we're going to try to reverse that. So, but the problem is that that these issues of particularly workforce skilled workforce, and the sort of cost issue are really front and center. I think Morris Chang also, though, is talking about, he believes very much in sort of the cultural aspect of this. So he's saying basically, look, the U.S. isn't really serious about advanced manufacturing because culturally, everybody's getting an MBA here. But if you want to run an advanced fab at scale, you need technicians in bunny suits that are willing to spend hours and hours a day in the fab. You need people who are willing to be on call 24/7 to service a tool in the fab. And so his argument is complicated. It's based on both sort of cost and then also on, I think, culture. Because TSMC has had a facility in the U.S. for a long time, sort of in Washington. And I think, so they understand, they at least claim they understand the cultural aspect of it. But to me, the workforce part is really the hardest part. So when we work with clients, for example, the big part of their application for chips is workforce development. But that's a hard thing, right? You can't really guarantee. You can set up an associate program with Arizona State University or Ohio State, whatever, right? Which all these companies are doing. TSMC is working with ASU is going to be a big beneficiary here. But you can't guarantee. Like right now, the sixth or seventh graders are going to be the technicians and the engineers in these fabs, right? So you can't guarantee that those sixth graders, for example, are going to go through the system and come out as a fully qualified engineer at the end of the day. So it's tricky. The workforce part is really tricky, and I think, but that's part of the goal, right? Is to sort of, okay, we need to exercise these muscles and we need to do that. But the problem is for companies, for example, it's hard because they can't sort of take a running leap at this. TSMC, for example, in Taiwan, they get 80% of the PhDs graduating from Taiwan universities go and work for TSMC. I think it's been 60 to 80%. I think the estimate is by the end of the decade it would be 80%. So they can count on a certain amount of work. They can count on their workforce. But here it's tricky, right? And then, for example, at TSMC in Arizona, they had a hard problem just finding technical people to build a clean room. You need a lot of clean rooms in a fab. And then, importantly, you need to be able to install things like the EUV gear, right? That's very specialized capacity. And so they were working with unions, the pipe fitters union 44444. And it turns out that, those unions and those workers don't have the skills, right? Not surprising. So they had to bring in hundreds of engineers from Taiwan. And then the unions were fighting that, even though they were bringing them in to help train them to not really replace them. But that's a huge issue. So the workforce piece involves not just sort of the engineers and the technicians to run the facility, but sort of how do you build these facilities and ensure that they're up to spec. Because TSMC can't take a chance with a $250 million piece of gear. Hey, you go figure out how to install that, and we'll hope it works, right? So, that's why they had to bring in the skilled people, and Samsung and SK are in the same boat, right? Because they have to install the complicated equipment, build clean rooms, et cetera, et cetera. So all the companies that are involved in the CHIPS Act are running up against this issue of both sort of immediate need for trained workers to build stuff, and then sort of the longer term, how does the education system crank out people who want to work in these facilities? This is not easy work, by the way, right? It's not sexy work to be in a clean room for long periods of time. So it's that gets to the cultural issue. So I think that the jury is still out a little bit on that. So when you say, do I understand the problem, it's just not clear to me that if we do end up building, TSMC facilities in Arizona, Intel in Arizona, Intel in Ohio, Samsung in Texas, we're going to have these sort of clusters. The question is I still think the jury's out as to how the education system, without, say, immigration reform that reforms the H-1B system, whatever. We need massive immigration reform. How we get to that at the end of the day, because it's a big issue. And then the other part of it is supply chains. How much of your supply chain do you bring to the U.S., for example? And that's a scale problem. So TSMC has 2,500 suppliers in Taiwan. They're probably going to bring 100 to Arizona, and then those suppliers have to have a scale. They can't just work for. So they've been taken to the Intel facilities, and they'll probably supply that. Because the problem is that the industry is really driven by cluster effect. Taiwan is essentially a whole cluster. You can put a technician on the train in Hsinchu and get him to Tainan or Taichung in minutes, in an hour and a half. I've taken the high-speed rail many times between those locations. And that's a huge advantage. So your workforce, for example, your technicians can service multiple facilities in a very short time. So if we have clusters in Arizona, Texas, and Ohio, you're not going to have that effect. So the problem then is how does the cluster and the supply chain around those facilities develop? Because that's a huge issue, and it's again, when the cost is the main. These are costly facilities, costly investments. So the sort of incremental cost of running those facilities have to be well managed. So when President Biden goes to Arizona and says, this is made in the U.S. It's good for U.S. consumers. Well, it depends, right? It's going to be much more expensive, actually. The chip, the companies like Apple and NVIDIA are going to have to decide how to pass that cost onto customers. But for example, the wafers coming out of that facility in Arizona, there's not enough of them to justify, for example, an advanced packaging facility in Arizona. So those are going to have to be shipped back to Taiwan and packaged, and then maybe shipped to China to be incorporated into something, or whatever. So even though they're going to be made in the U.S., the rest of the downstream supply chain will not necessarily be in the U.S. For example, I'll just give one quick example. GPUs. All the GPUs in the world are made and packaged right now in Tainan. I was sitting in Tainan Science Park a couple of weeks ago, and within a mile radius of me, all the GPUs are made and packaged. But the packaging is the really key element there, and that's what the bottleneck is. That's why there's a big shortage of GPUs. And there's no justification to build. That's a $3 billion facility to upgrade. They're just doing that to Fab 6 in Tainan. And there's no way that you could justify putting a packaging facility like that in Arizona, when even if all the chips coming out of that were GPUs, because it just wouldn't achieve the scale to justify that. So that's the problem with reshoring is it's sort of
Problems.
Right, yeah, there's multiple problems. That's not saying that those aren't overcomeable, right?
Sure, sure.
But the question still is, when we wake up in 2030, what percentage of advanced chip manufacturing will be in the U.S.? Or what percentage of chip manufacturing in general? I just saw a study that said it will be 8%. Now, the goal, I think, one of the goals is to get the U.S. to 20% by 2030. But the reality is we'll probably go from like 7% to 8 or 9%, just because of these economics and some of these problems here. So it will not be insignificant, but it will not be enough to move the needle to reduce dependence on Taiwan, for example, for advanced that.
No, thank you. I mean, there's so much there. I can't help but think of the movie Field of Dreams as though, like, if you build it, they will come is the idea behind this. But we have to build it, right? And you outlined some of the workforce issues with that, and then they may not necessarily come. Or some of these ASU grads, they go to TSMC's fab specifically for a few years, put that on their resume, and then they get headhunted elsewhere and leave, right? And so.
Yeah, there's the pay structure, right? I mean, you can get an entry-level engineer, software engineer can go to Google and get a huge salary differential. The problem is that it's also it's the type of engineering. It's really hardware engineering. Japan is grappling with this too. They're trying to make it more sexy in Japan to be a hardware engineer, because they have their own version of the chips, the sort of long-term strategy. They've decided to go very narrow and target, really advanced packaging and 2 nanometer technology, and not try to compete at some of the other parts of the sector. But their challenge is also is still the workforce issue.
Given time, I as you know, I have other questions, but
Sure.
we have some folks here, so I want to give
Absolutely.
anyone, if in-house or if there are questions online, a chance to pose a question to Paul. Is anybody here? We have a mic, so if you do have a question. We have one online? Okay, what is the question online, Andy?
Sure, thank you. The online question is, China announced some countermeasures to retaliate for the October 7th restrictions and other U.S. government actions. So for rare earths, Micron, and Apple sales, what are potential risks from retaliation for Korean companies?
Great question. So we get asked this all the time, of course, by clients. So the Chinese response function has been very interesting to see, because up until really this year, they hadn't responded significantly. And so even though, for example, they rolled out in May of 2019, they rolled out this so-called unreliable entities list, which was sort of an analog to the U.S. entity list. But they hadn't actually used it until this year when they used it against Raytheon and Lockheed Martin for Taiwan arms sales. So starting the beginning of this year, our assessment for clients is that China will respond, right? But the response that China will take is very complicated because they don't want to do things that will disadvantage their companies or disadvantage their economy, or further poison the business climate, which is already pretty tricky in China, right? Because of big drop off in foreign investment, et cetera. So that they're trying to be careful in how they respond. The Micron targeting, I think, was very specifically responding to this YMTC being a target of both October 7th controls and then in December being placed on the entity list. And nobody in industry was surprised by this because Micron had been known to be sort of outspoken in wanting YMTC to be subject to some of these controls. And so nobody was surprised by this. But again, the terms of that are still being worked out. So it might turn out that the hit on Micron sales in China may be not as bad as originally thought. They might be restricted from some parts of Chinese critical infrastructure, but it may not be as bad. They've been just yesterday. There was a story in the media story that the CEO of Micron had met with Chinese Minister of Commerce, and so they have investments in China, so they're working through all this. The materials piece, I think, is the most complicated one and maybe the most important one because when I mentioned the Sullivan Doctrine, which was that the U.S. was going to treat these three sectors as most important, the third sector, green technology, is a reversal of the first one, where U.S. companies and Western companies dominate those supply chains. In the third category, green tech, Chinese companies dominate those supply chains, and we're talking here about critical minerals. There really are like 70 critical minerals, right? And each one has its own specialized supply chain. Rare earths are really important, for example, for magnets. Rare earth magnets are used in EVs, and they're really critical, for example, to make sure the battery in an EV is used most efficiently with the motor. So you need rare earth elements and batteries made from them to really, the green tech revolution is probably impossible without rare earths. Wind turbines use them. It's a matter of efficiency and gaining the sort of economies of scale with energy use. So, but it's complicated because those rare earths, for example, are sent to intermediate providers and then to a variety of end users. So unlike in the case of the U.S., which has put controls on specific Chinese companies or specific end users, and they're sort of identifiable. Here, if China decides to control these materials, for example, the impact of those controls is less clear, right? Than if you're targeting a particular technology going to a specific company, because it's going into a broader supply chain where there may be 2 or 3 intermediate steps before you get to the final product. So last summer, in response to media stories about updates to the October 7th controls that were eventually issued on October 17th, the Chinese announced these controls on graphite or on the gallium and germanium. And gallium and germanium are used in the semiconductor industry. And so South Korean companies got a little bit concerned about this, as did many companies in the industry. Now, gallium and germanium are used in a lot of different things, but they are critical for certain kinds of semiconductor production. But so far, the Chinese haven't restricted those exports, and this included a number of compounds too, like gallium arsenide and gallium nitride, which are really important for certain kinds of advanced semiconductors. But they're putting these controls in place, but they haven't actually pulled the trigger in terms of how they're going to use them yet. I think they're putting in place tools, then they will decide how to use them depending on on the situation. And then in response, of course, to October 17th, they put these controls on graphite. Now, graphite is really important because Chinese companies control 90% of the graphite, both artificial and man-made graphite, or artificial and natural graphite exports, and that's a critical component of EV battery anodes, right? And it turns out, of course, that South Korean companies, LG and SK, the battery part of that SK, are critical users of graphite, and that's the case with Japanese companies and with Chinese companies, of course. But again, they put in place this control. I don't think they've pulled the trigger on this. That is actually would have a much more potentially more direct impact if they cut off the export of certain kinds of graphite. And it depends on how they do that, because graphite is a commodity, but then for EV batteries, it turns out Chinese companies also dominate the IP for producing the sort of qualled battery graphite components. And so that's even more important than the material is the IP. And they could also control that too, going to specific companies. And that could, for example, if they decided to restrict graphite anode quality materials to South Korean companies, that would be a big deal in response to. But again, they're retaliating for something here, right? They're not going to put these controls on for no reason. So, and again, that's why South Korean companies operating in China, do not want to run afoul of the Chinese system and see retaliation, right? And this is in general the case with, for example, U.S. toolmakers or the Dutch toolmakers, the Japanese toolmakers. They're worried about retaliation in China for some of these controls, right? Now, we haven't really seen that yet, but the Chinese, could respond in a very targeted way, for example, and now they have these tools, both graphite, and then the latest thing was the rare earths. It looks like it's just a notification, a transaction. I don't think they put a licensing requirement on this. They want to get visibility on this, I think, where all the rare earths elements are going, because, this is a big field. So I think it's a first step to try to understand where the rare earths are going, and then they will develop a way or a strategy to selectively use that tool. But they have to be very careful too, right? Because when you start getting into materials, these are markets, although they're not really markets. They're not like commodity markets like oil or other things. They're more complicated than that because there's a lot of intermediate steps in the process. But since their companies dominate those supply chains, they're going to use those supply chains. But I think they haven't figured out how to do that yet in a targeted way. But it's coming. So keep an eye on this.
I have each response you give. It raises further questions that I want to ask. We are running up close. We're a little fast on the clock. So I'm going to give anybody in the audience, if they want to pose a quick question. No? Okay, just
Got a question. Come on.
Josh, no?
Josh has a question.
All right. Really quickly, so you mentioned in the paper, of course, South Korea has received another waiver, sort of an indefinite waiver.
Yes.
On the 2022 export controls, the exports of semiconductors and chip making equipment in China. One question I have is, so they've received this waiver, but do not the national security guardrails, the 5% and 10% restrictions on more advanced and legacy facilities, wouldn't that itself impose a degree of control as well? Because you have to bring in certain machinery to upgrade these things, right? So they've gotten a waiver, but essentially the broader question is, how dependable is this waiver? And of course, we have a presidential election here next year. And given the amount of investment and the timescales involved in these firms planning, their uncertainty must be just hardly mitigated.
Yeah, it's a good question. And it gets to...
And we have very, very little time. Sorry.
Well, it gets to the issue of what is considered investment, right? And what's considered sort of ongoing maintenance or support to the facility, right? Because I think my sense is the intent of the guardrails is to prevent the companies from expanding those facilities, expanding the capacity. So I think that's what that 5 and the 10% number is really directed at. I think though that the ongoing maintenance and support part of it will probably not be as impacted. Now I think it comes down to the original intent of that whole guardrail issue was to negotiate a sort of one-on-one agreement with the Commerce Department so the Commerce Department understands the roadmap and understands, what's going on here. Because as you rightly point out, these facilities are constantly, the next generation of tools has to be commissioned, and then it takes, months to get them designed, installed, et cetera.
This is part of the upgrade,
process.
Right?
Yeah, and that's part of upgrading them up until a point, right, where they're going to need to be upgraded to say EUV, and then that, then there'll be a complicated calculus as to what to do then. So the problem is that these controls are being decided by an administration, and that administration might not be there in another year or two, right? And so that's also creating some uncertainty here. So how all this is going to be implemented, I think they're going to try to lock in some of this in this negotiation and try to clarify some of these things. But there's still a lot of uncertainty. This has never been done before, right? Trying to define what a company can do or not do to invest in facilities that it already has, $25 billion of capex in. So it's complicated. But I think. So yeah, I may have, and I may want to clarify some in the paper. This issue of uncertainty is really critical, right, for companies that are in this business. And so, does that inclusion on the unverified list really relieve that particular uncertainty? And then how do the guardrails interact with that? And it's tricky. I don't know. I can say definitively that's all been worked out. The details of that. But so I think there's additional uncertainty there. Okay. Absolutely.
Well, Paul, thank you so much. I say this every time. An hour is never enough time. But of course, the paper will lay this out, and there'll be further updates just based on our conversation today.
I'm sorry. I had
No,
I have a lot of writing commitments, and this was really important but it's hard because it's complicated. Once you get the basic stuff organized, those kinds of details are hard because you really have to. Some of this it's not easily available. You have to talk to a lot of people and figure out where the actual needle is on that.
Well, this is expressly what an event like this is exactly for. So
I appreciate I appreciate you reaching out because it really requires some sort of really focused look on this to understand sort of where we're going on this, because it's not the media coverage is okay, but it misses a lot of
we want to get a
the
little
nuance, which is where the devil is in the details here.
Well, thank you for laying out so many obviously interlinked and complex details, and thank you for joining us. We will, as I said, be publishing the whole issue before the end of the year, which will also include a paper to a point Paul raised on South Korea's energy security and critical minerals, which is next Wednesday. James Bowen from the Perth U.S. Asia Center, which is a foreign policy think tank based in the University of Western Australia. He's making a long trip to come join us here. He'll be presenting his paper, The Raw Materials of Economic Security, South Korea's Evolving Energy and Critical Minerals Policies.
I will definitely want to come to that.
So please do. This will be a hybrid event as well.
Yeah.
Same time, 10 to 11 next week. Thank you, everyone, for joining. And for those online, the link to RSVP for in-person or hybrid is online right now. So thank you again, Paul, for joining.
No, these are the issues of the day here. I mean, there's nothing more important than, semiconductor supply chains and EV battery supply chains.
And South Korea, for better or worse, is smack dab in the middle of all of these things. So, well, thank you, everyone, for joining us.